All right, welcome to today's video notes. We're going to be focusing on angle relationships today and identifying names for different types of angles and angle pairs that exist. So let's dive right into it. We've got diagrams here of different types of angles, and this one actually the diagram didn't make it on the page, so let's draw that real quick. When you have two angles that are created by common segments, those angles are called vertical angles, and they share a common vertex, and they're made by two intersecting lines. Likewise, the ones I haven't labeled off to the side, these two are also vertical angles. We could call them vertical angles C and D, but it's the pair that makes them the vertical angles. The next angle are two angles that are side by side. So side by side would be adjacent angles. And adjacent angles share a common vertex as well, and they share a common edge. So that's what makes them adjacent, is the common edge. The next type of angle that we have is the linear pair. And this is a type of adjacent angle. We've got these two angles that are adjacent to one another. They sit along the same line, so they create a linear pair. And the sum of angle A, so the measure of angle A plus the measure of angle B, let's use a lowercase b, is equal to 180 degrees. That's making it a linear pair. A word that sometimes is thrown around in geometry for this type of relationship between two angles, if they add up to 180 degrees, then they are supplementary angles. So they don't have to be a linear pair to be supplementary, but all linear pairs are supplementary. Kind of like all squares are rectangles, but not all rectangles are squares. Here we have angle A and angle B, and those two angles are called corresponding angles. And what we have is two lines that is cut by what's called a transversal. It's the line that transverses both of those. Okay. We have another transversal going here, so we've got a transversal line cutting through these two lines, and they're angle A and angle B. These are on the interior, and so that's what the I is for. They're interior, and then they alternate sides of the transversal, so they are alternate interior angles. They're between the parallel lines. Now, if these lines are indeed parallel to one another, then A and B are going to be the same size, the same measurement. Likewise, on the corresponding angles, if these two lines that are cut by the transversal, if those are parallel, then A and B are the same size, or we use the term congruent. And then similarly, the last one, we have a transversal cutting through two lines, and so angle A and angle B, those are on the exterior or the outside of the parallel lines. And they alternate sides. So they're alternate exterior. And again, if these two lines are parallel, then A and B will be equal in measurement. So that's the names of 6 various pairs of angles, and we're going to be focusing on using the fact that the transversals, when they're parallel, we have congruent angles. So the alternate interior, the alternate exterior, and corresponding will all be congruent angles given that the pair of lines is parallel. Vertical angles are always congruent, and so that's what we're going to see in these diagrams below. We have this type of angle here, and those two angles are called vertical angles. And and we know that vertical angles will always be congruent. Therefore, we're able to say that B is 38 degrees because the two angles are congruent. Okay. Right here we have two angles that are side by side, so these are adjacent angles. Adjacent angles. And because we've been provided the information that this is a right angle overall, we're able to conclude that B plus 55 degrees is equal to 90 degrees, and we use that to conclude that B is equal to 35 degrees. We subtract 55 from both sides, and now we have the measurement of B. In the next diagram, we have a linear pair. So this is a linear pair. The angles are adjacent, and they rest on a common base. Therefore, the sum of the two angles is 148 degrees. So we can say B, I think I said that wrong. The sum of the two is 180 degrees. So B plus 48 degrees is equal to 180 degrees. If we subtract 48 from both sides, we find that the measurement of angle B is 132 degrees. So, okay. Moving to the next diagrams. This here we have two parallel lines cut by a transversal. I know that these lines are parallel because this triangle here, which I'm going to make bigger, and this triangle here indicate to me that symbolically that the lines are parallel. And because the lines are parallel, my corresponding angles are going to be congruent. Likewise, I could say alternate interior, alternate exterior, or are also congruent. But these are corresponding angles. Corresponding angles. And thus they are congruent. So I can say one angle is equal to the other angle. And if I were to start solving this for x, I could subtract 1 from both sides and then divide both sides by 5, and I find that x, oh, that fell off the camera, x is equal to 27. So, okay, finally we have three angles here, and these three angles are all adjacent angles. 99 and 207 are adjacent because they share this common edge. 99 and x plus 20 are adjacent because they share this common edge. And x plus 20 and 207 are adjacent because they share that common edge. We've accounted for all of the angles in a full rotation, so we're able to deduce that because it's a full circle, and a full circle has 360 degrees, the sum of these three adjacent angles is going to be 360 degrees. So we can write the equation x plus 20 degrees plus 99 degrees plus 207 degrees is equal to the full circle of 360 degrees. If on the left we add the 20, the 99, and the 207, we're going to get x plus 326 degrees is equal to 360 degrees. And then if we subtract 326 from the left and the right, we arrive at x is equal to 34. Okay, moving on to the second half of the lesson, we're going to introduce a few symbols that we're going to use throughout the course, and then use them to establish truth or false within a diagram. So this symbol here represents perpendicular, and it's referring to two lines that meet or intersect at a right angle. So technically the symbol stands for perpendicular, but what that means in our mind is that there's a right angle at their intersection. Kind of like the drawing suggests, a right angle. The next diagram represents parallel. So when you have two lines that are parallel, we could use this symbol to refer to the lines being parallel. And we're going to see that below, like down here. Line CD is parallel to line AB. This symbol here represents the term congruent. So what we'd be saying is this shape has the same size and same angles as another shape. And we see that down here. We're asking the question, is this angle congruent to this angle? So are the measurements of the angles the same? So this is like equals, but it's equals for shapes. So we don't use the equal sign. We create a new symbol that represents congruency because you're talking about the shape of an object, not so much the properties of the object. So, and then this tilde represents similar, and we use it to say two shapes are similar. And so to give a quick example of two shapes that are similar, this triangle and this triangle are similar. They're just not the same size. And they're similar because if I put in here that they both have right angles and they both have 45-degree angles, all of the angles are the same. That makes the shapes similar, but the lengths might be different. Like this might have a length of 2 and this has a length of 5. So similar means that you can zoom in or zoom out on the shape and it would be similar looking. But same angles, but not necessarily the same size. Okay, we're going to check to see if these statements are true or false based on the diagram. And what we have here is two sets of lines that are intersecting. Note that we have this symbol here of the triangle, which tells me that this line is parallel to this line. So these two lines are parallel. And then the double triangle, and the double triangle would be saying that line DB is parallel to line CA. So the question is line CD parallel to line AB? Well, line CD is this, and line AB is this, and because we have the parallel triangle markers, we know that this is a true statement. Now we're setting the foundation again for geometry. Further down the road, we're going to use this relationship of knowing that lines are parallel to make calculations. For example, stating that alternate interior angles are congruent if the lines are parallel. Okay. The next question here says, is line segment TV congruent to line segment ST? So they're asking, is the size of this segment right here congruent to the size of this segment? Let's grab a highlighter. Is the purple portion congruent to the yellow portion? And visually they look to be about the same size, but we don't know. They could be off by, a millimeter, a tiny distance, a nanometer. So we're forced to say that this statement is false. It could be true sometimes, it could be false sometimes. If we wanted it to become a true statement, what our diagram should look like is we would put a tick mark here and a tick mark here to indicate that this line segment is the same length as that line segment. But since there are no tick marks, we cannot deduce they are the same length. Next up, is the angle VWX so is VWX congruent to angle WVU? So WVU, are these two angles congruent? And because we have the arc here indicating that this arc is the same symbol as this arc, we know that this is true. Right? If it were false, we would have a diagram that was without arcs. For example, maybe this had an arc, but this one did not. Or this was considered a double arc, in which case the angles are clearly different than one another because we're saying so with the symbols. But because they have the singular arc, we know that they are the same size, the same measurement. And we're going to use that same approach here on the last one. Is angle XYW congruent to angle TYU? So XYW is a single arc, and angle TYU is also a single arc. So because both of those are single arcs, they're declaring that those two angles are the same. So I'm going to write this as a true statement. Notice the matching arc. Also, I would like to point out that if we were told that XU and TW are lines, then we would have a vertical angle. Then XYW and angle TYU are vertical angles. And if they're vertical angles, then they would be congruent. But we are not told this statement, so I can't use that as justification because I don't know whether there's a bend as we pass through Y going to U. But that's really kind of digging deep into thinking about the full implications of the problem and what you're provided in the diagram. So thank you for watching. Be sure to comment, like, subscribe. I'm going to go ahead and throw up the closing problem for you to take a look at, and then after you pause the video, I will show the solution to this. So go ahead and pause the video here. All right, since they are alternate exterior angles, we're able to say that they're congruent because the lines that intersect the transversal are parallel. Because that, we're able to say 46 degrees is the same measurement as 5x plus 1 degrees and use that to solve for x. Thanks for watching. Have a good day.